next up, we have a very short session that Fraser's going to present to us on Identity 2.0, the how, where, why. I didn't read it all. Federated login, something like that.
Something like that.
Fraser's joining us from Red Hat up in Brisbane, where he works on free IPA identity management system and the dog tag certificate system. He's a member of the Brisbane functional programming community, enjoys types, occasionally writes Python. Please join me in welcoming him.
Thanks, Brian, for the intro. So this is, as Brian said, to talk about federated identity and social login. We're going to look at what it is, why you should care about it, and how you can use it, including an extensive demo of one particular approach of using external identity providers to authenticate your users on your behalf. The executive summary of why you would want to do this is that authentication is hard to get right. And we will go in a little more detail over each of these points, but basically authentication is hard to get right. You want to avoid data silos, particularly within enterprises behind your corporate firewall where you work. Not as big a concern for sort of public-facing applications and startups and that sort of thing. Authentication is a burdensome activity for users, and the burden actually causes users to make poor decisions and put themselves in jeopardy. The user is often already authenticated by someone. So if you want to trust someone else to do your authentication for you, then you can basically outsource that and reduce the amount of work you have to do and reduce the amount of risk you are in and the amount of risk that your users are in by relieving them of the need to authenticate specifically to your service or site. The very high-level view of what federated authentication is in this diagram. Now, we're going to see this diagram, well, the entities in this diagram repeatedly throughout this talk. So on the left, we have a user agent, UA. That is a browser, presumably acting on behalf of a user, so carrying out a user's intentions. In the middle, we have the service provider, and you'll see that abbreviated as SP. So this is a website either out on the internet, bobswidgets.com, or within an enterprise. This might be some customer management system or something along those lines. So an internal service for an organization. So the user agent, on behalf of a user, issues an HTTP request to the service provider. Hey, get me this thing. I want the thing. And the service provider doesn't know who the user is at this point. And then the service provider delegates an authentication request to some identity provider. Out on the internet, that might be login with Facebook, social login provider. Within an enterprise, it might be an LDAP server or a corporate identity management system like FreeIPA or Active Directory. So the service provider basically delegates to the identity provider, IDP is the abbreviation you'll see. And we'll ask the IDP, who's this? Who's trying to get the thing? The IDP will do some work to authenticate the user, and if the user is able to successfully authenticate, the IDP will return control to the service provider along with an assertion about who that user is. In this case, it's Alice. And the service provider can, at this stage, perform authorization checks as distinct from authentication. And if the service provider is satisfied that Alice is allowed to have the thing, then it can return the thing. Here you go. Just spend a little time talking about authentication and authorization. So authentication is specifically determining who someone is. Is this person, who are they, or are they who they say they are? Authorization is this person allowed, or is this entity allowed to do the thing they're trying to do or asking to do? this talk is focused almost entirely on authentication. So we're not actually going to talk about how the service provider makes the decision as to whether Alice can have the thing. Okay. So who are the identity providers? So I've mentioned two main classes, and we are going to be sort of switching between these two contexts a little bit throughout the talk. Hopefully I'm going to clearly demarcate what is relevant to enterprises and what is relevant to social login contexts. The social login providers are organisations like Google, Facebook, Twitter, LinkedIn, GitHub, which is not as big as the others, but obviously relevant to what we do and the sort of services we as people in the tech community might be interested in using. There are probably hundreds of others, but chances are those will cover most cases that you'd be interested in. And the enterprise context, as I mentioned before, an identity management system within your organizational perimeter, which may be Active Directory, free IPA, or it could just be a bare LDAP server, which is a directory service protocol. So why do we care about social login? We're going to look in a little bit more detail about the motivations for the different entities involved, so for users, for service providers, and for identity providers. For the service provider, part of the motivation is not wanting to deal with passwords. Passwords are secret. They need to be handled with care, and you don't want to leak them. A lot of you will be thinking, well, it's not that hard. And we saw some talks earlier, Lily's talk yesterday. How do you keep passwords secure? Well, you salt them and hash them. That's all you need to do, right? But we see time and time again as an industry that we actually can't get this right. So, yeah, probably most people in the room have used some of these services at least that have had massive password breaches. Often what's been leaked is not a plain text password, but a salted and hashed password. But even just leaking that exposes that artifact to offline attacks. Whereas if an attacker wants to brute force a password without access to the backend systems or a dump of the database, they have to do it all through HTTP, and it's easy to rate limit, it's easy to detect and shut that down. But once they've got the database, even if that password is salted and hashed, they can just set a GPU to task and say, go and crack this password. And unless the user is very good at choosing passwords, chances are they're going to get popped at some point. Yeah, hey, that's my email address. I'm owned. So yeah, if you go to Have I Been Owned, this is run by Troy Hunt, this service, and it's basically a database of password breaches, sites that have had their user and password stores leaked, either hashed or salted and hashed passwords or plain text passwords. And you can go and see if your credentials have been compromised in some way in the leaks that are known and archived at this site. So yeah, 4 breached sites for me. One of the important motivations from a user point of view for why they might want to use federated or social login is just the burden of having so many different identities to manage and to actually go through the motions of logging in at every different site that they need to use, every different service. For this part of my talk, I wanted to just go through a list of the services I use and kind of find some category. And the one I came up with was sites for buying tickets to events. And I have accounts with five different providers, and they're the ones you see on the screen. And each one, I have an email address, which is my email address, obviously, and a separate password for each one. And every time I want to go buy a ticket, I've got to log into the particular one that I'm using. And why should we need 5 different identities, 5 different sets of credentials to log in 5 different services to do just one thing? And it's important to remember that a user doesn't go to your service to log into it. That's just something that's getting in the way of them doing what they actually came to you to do. So if we can get out of their way and leverage some identity that they already have, we relieve them of one additional identity that they have to manage. And if they're already logged into the upstream identity provider, they often don't have to log in again. And so without actually getting in the user's way, you can authenticate that user and just let them get straight onto what they came to do. So it's a good user experience to avoid the login form if you can. So social login, Katie Bell's talk just before lunch talked a bit about this as well if you were there, but who's seen a login form, if you will, like this, a login interface where it just says sign in with Facebook or Google? I mean, has anyone not used something like this to log into a service? There's no hands up. So we've all done this. And I'm sure we all appreciate the convenience of it. We get to use an existing identity, don't have to create a new identity. And if we're already logged in, we just get in. So from an identity provider's point of view, why would you want to provide this service? And I am speculating a little bit, but there's obviously the motivation that if users see, oh, I can log in with Facebook, log in with Google, that increases your brand exposure for starters, if you can convince service providers to leverage you as the identity provider. The other reason is that as an identity provider, you get data about what your users are doing. You get to learn where they're logging in. And if you're Facebook or Google, you're actually an advertising company. The users are the product. Getting that information about the user is actually valuable to these companies. It's a cynical way of looking at it, but it's the truth. So we sort of get onto the topic now, why would you not want to do this? First of all, if you're going to use social login providers, and again, this slide's more relevant to the social login context. Not everyone uses Facebook or Google or whatever. You saw on the previous slide, you can actually offer multiple social login providers to log into your service. But no matter which set you choose, there are going to be people who visit your site who don't use any of them. And this has happened to me on several occasions where a site has only offered social login, and I don't use any of the providers that they are offering for me to log in with. So, sorry, you just lost a user. You've got to consider the trade-off here. I mean, I can't tell you that you should or shouldn't do this or which identity providers to use, but you definitely need to think about the consequences of going to a social login only paradigm and who you might be excluding if you do that. So not everyone uses Facebook or GitHub, and even if they do, because of the privacy implications that we mentioned on the previous slide, where the identity provider learns about where their users are logging into elsewhere on the internet, a user might not want to make that privacy trade-off even if they do use Facebook or LinkedIn or insert identity provider here. Or they might not want to associate their identity on that site with your service, or they might not want you, the service provider, to know about their identity on Facebook. Who am I on Facebook or on LinkedIn or whoever? So there are good reasons why users might not want to use social login providers or particular social login providers at a service. So again, you need to think about the implications of which providers you use and what methods you use for login on your site. Finally, these protocols for social login, for federated login, have a lot more moving parts. The protocols are far more complex than the user and password paradigm. With user and password, you dish up a login form straight to the browser. The user fills it in and posts it straight back to the server. That's it. 2 entities, one page and one response to that form from the user. And that's enough for the service provider to authenticate the user. We'll see in a slide or two, right now actually, just how much is involved in federated sign-on. So again, the same 3 entities we saw on the high-level overview slide before, but now we're actually going to look sort of at the protocol level, what's going on. Now, there are 2 protocols that are in widespread use for federated sign-on. Those are SAML and OpenID Connect, or SAML2, I should say. This diagram is not dealing with either one in particular. They work in similar ways. They both involve more or less the same number of requests and the same flow that we're going to detail here. The message formats are different, but just to emphasize to you that this flow that we're going to go through now is still abstract in the actual protocol used. So it starts with the user agent requesting a resource on behalf of a user from a service provider. That request can also include things like posts. So when I say request, it's not just, hey, give me this thing, but it's also actions like publish this thing. Anything that a user, any interaction that a user might want to have with a service provider as a particular user. So user agent sends a request to the service provider. If the user is already logged in, so has an active cookie-based session with the service provider, we're done. Right? The service provider has all the information it needs to authorize that action and return the appropriate response. And we're done here. We can all go home. But wait, if they're not logged in, the service provider then responds with an HTTP redirect to send the user agent over to the identity provider. That redirect will contain 2 essential pieces of information. First, it will identify who the service provider is. And second, it will tell the identity provider where to redirect back to after the identity provider has authenticated the user. If at the identity provider the user is not logged in, then the identity provider has to authenticate the user, and in the common case, it will send a login form to the browser. I use the solid line here because this is something that the user actually experiences as part of the user experience, whereas the dashed lines are things that are happening in the protocol, things that the user agent is doing, but that the user is not involved in directly. So the user doesn't actually experience as part of something they're actively involved in, this redirect happening. It's just something that the browser does. Okay, so the user here sees a login form, they enter their credentials and post that back to the identity provider. The identity provider can now authenticate the user, and if the user is authenticated, the identity provider then, using the redirect URL that was included in the initial redirect to the identity provider, redirects the user agent back to the service provider. That redirect URL will contain what at this point we'll just call a token. And a token is either an identity assertion, so some verifiable assertion made by the identity provider about who the user is, and possibly some other attributes. Or it is a token that the service provider can use to obtain a verifiable identity assertion from the service provider. If it's the latter case, that's what this step here is, get user info. So it will then use the token to obtain from the identity provider an identity assertion. This step occurs in OpenID Connect, but not in SAML. And then finally, the service provider knows who the user is able to authorize the action and return a response. Okay. Is everyone still with me? Cool. Oh, one thing we didn't cover, if the user is already logged in at the identity provider, then there's no need to send the login form. So in that case, even though there's all these redirects happening at the user agent, all the user sees, or all the user is actively involved in, is their initial request to the service provider and a response from the service provider, even though their user agent is bouncing all over the place to perform the rest of this protocol. So that's if they're already logged in. Otherwise, the login form. Okay. So a bit more about the two main protocols in this space. So SAML2 is an XML-based federated sign-on protocol. It was standardized in 2005, so it's quite old. And it's very enterprisey. It comes from the enterprise authentication space. That's sort of where it began. It does work fine for social login. It just happens to not be used much for that at all. But it does cover that use case. It stands for Security Assertion Markup Language. Yeah. If there's time, I'll show you what one looks like. But it's just imagine lots, like a screen full of XML. And yeah, that's really all you need to know. OpenID Connect is a much more recent standard. It was finalized only a few years ago. It's based on OAuth 2, which is an authorization protocol. OpenID Connect is an authentication layer on top of OAuth 2. The messages are JSON, and the identity assertion payload is what's called a JWT, or a JSON Web Token, which is a cryptographically verifiable assertion that contains the user's essential information. Yeah, and so it comes from the social login space. But again, it's applicable to the enterprise use cases. So even though they've come from completely different domains and different motivations, the two protocols, as we just saw on the previous series of slides, actually work quite similarly and are more or less equally applicable in both cases. The footnotes there are just links to the specifications. These slides will be available online now, actually, and I'll give you the link at the end. There'll be quite a few more footnotes, so I don't expect you to read that or visit that now, but you can later if you want more detail about the protocols. Okay. So we need to take a little diversion and talk about identity brokers. So in the discussion of the protocols so far, we've talked about three entities: the user agent, acting on behalf of a user, a service provider, and an identity provider. In a lot of cases, it is useful to introduce a fourth party into the mix, and that's an identity broker. The identity broker basically sits in between service providers and identity providers and is able to manage realms where you're connecting service providers to identity providers in a many-to-many relationship, or potentially many-to-many. So it allows you to easily add new identity providers to a particular realm, remove them, define new realms, and in an enterprise setting, this is actually a very useful thing. For a general public-facing web service, it might still be useful to use one just because they can relieve you of some work that you might otherwise need to do, which we may discuss a little later. Yeah, and they support multiple identity provider and federation protocols, so they can also act as adapters. So if you have a service provider program that only understands OpenID Connect, but you need to connect it to an identity provider that only talks SAML, you can put an identity broker in the middle and it can basically translate between the two protocols. What does this actually look like in practice if we extend our diagram from before and add the broker in? We see that there's twice as many redirects, and other than that, it's more or less the same. So user agent hits the service provider redirects to the broker. The broker then redirects or otherwise communicates with the identity provider. The identity provider authenticates the user, and then a series of redirects to unwind this stack, if you will, occur, and eventually the service provider has the assertions it needs and can authorize and respond to the original request. There are various identity broker implementations available. One of them is Keycloak, which is one that we work on at Red Hat. I don't work on it directly, but it is sort of within the umbrella of identity management technologies at Red Hat. So it's open source. It's a Java program running on JBoss, but you don't really need to know that, and it doesn't really matter. It supports a bunch of social identity providers, as well as SAML and OpenID Connect, and can also talk to LDAP servers and can consume Kerberos tickets as a means of authentication. Acting as a service provider to, so for talking to service providers, it supports SAML and OpenID Connect. So if your service provider is connected to Keycloak, it can talk either of those protocols. And that's where the adapter capability comes in, because if it talks to a SAML IDP upstream and an OpenID Connect service provider on the other side, then you can get around protocol mismatches that way. It's available as a commercially supported offering called Red Hat Single Sign-On, and there are Docker images available. So as I said, it's a Java program, but you can just avoid those details and run it up in Docker or OpenShift or Kubernetes. So, demo time. Let's take a sip of water. Right, so things we're going to see in this demo. I'm just going to skip that slide. Easier to show it in diagram form. Okay. So we're going to set up two different single sign-on and federated login scenarios for this demo. We'll do them one after the other. The first one that we want to do is to connect our application, app.py, running on Apache, to Keycloak using the SAML protocol. So our app is going to use Keycloak as a service provider. And then Keycloak is going to broker the authentication onwards to GitHub. So our application is, via Keycloak, going to have social login with GitHub. The protocol in between Keycloak and GitHub is OAuth2, which is fairly common for social login providers. This is the flow that's going to happen. So the browser I'll use is Firefox. So we'll see it send a request to the application. The application will redirect to Keycloak. Keycloak will redirect to GitHub, where I will then authorize the use of my identity with Keycloak. Then it will redirect back to Keycloak and back to the application, and we'll see in the application that the authentication has succeeded and the application has learned about the attributes that GitHub has included in its identity assertion. So I'll get into that now. Okay. Right. So this is a Keycloak installation that I have just running locally on. It's in a VM in my machine. I can log into the administrative console for Keycloak. So this is not a login for my application. This is just so I can log into Keycloak and define the identity provider and the clients. So this is actually where I'm going to log in to establish all of the connections that we saw in the diagram. We'll get to that in a moment. This is my application. As you can see, it is very pretty and Web 2-y and everything. So if I just refresh this, we'll see, okay, I'm not logged in, and we see a couple of request variables that the application has read from the request environment and is just reflecting back to the browser to tell me a bit about what the application knows. The configuration for my application is that. That's it. So it's just a Whiskey application, app.py, and the rest of the Apache configuration, just to allow that file to be read by Apache. This is the entire application. Basically, all it does is it enumerates everything in the environment, and if the environment variable starts with remote or OIDC claim or Madelon, what are those things? We'll get to that in a minute. It will reflect those environment variables back to the browser. And that's it. The details aren't really important. All you need to know is I'm not running a framework. It's just an extremely simple Whiskey application that's just going to show us what the application knows in its environment. Okay, so back to Keycloak. I will now log in to the Keycloak administration console. Oh yeah, I meant to delete that realm before I started. So now it's been deleted. So the default realm in Keycloak is master. That's the realm that I've logged into as an administrator. We're not going to use this realm with our application. We're going to create a new realm. This realm we will call social. Because we're doing social auth. And here on the left side in configuration is where we can add identity providers and clients or service providers. In the identity providers dialog, we see here to get started, select a provider from the drop-down, so we can have authentication get brokered on to SAML or OpenID Connect identity providers, or one of a list of social identity providers that Keycloak already knows how to communicate with and how to get the user attributes from. And so we will define a GitHub identity provider. The redirect URI that it's given us here is the redirect URI we need to give GitHub when we define our application, which we will do right now. So this is my GitHub account over here. I am logged in already to GitHub. And if I go to settings, oh, no internets. Let's fix that. Oh, good. Okay. We're back in business. Okay, so this is the GitHub settings page. There'll be a similar process for almost any social identity provider in terms of creating an application, registering the callback URL, and so on. In developer settings, no OAuth application. So these are applications owned by my GitHub user. I don't have any, but I'm going to create one. Register a new application. We'll just call it a, oh, that looks like an appropriate name. Yep, that'll do. That's just metadata for the app. This is not actually relevant to the protocol. And the callback URL, which Keycloak has told us. So we'll just copy that, paste that in there, register the application. Now, here we have a client ID, which is public and will be included in the redirect from Keycloak to GitHub, and the client secret, which must never be publicly revealed and is to be known only by your service provider and GitHub themselves, or the social identity provider. So we can copy these back into the Keycloak console. So here's our client secret. So yeah, I'll be deleting this application, removing the credentials after the talk. Naturally. Now there's nothing else we need to configure here. As you can see, there's a whole heap of different settings, but the defaults are fine for our purposes. So we've created the GitHub provider now, and we now need to create a SAML client. So client here is a client of Keycloak, which is the service provider from the perspective of the user. We'll call this F26 PyConAU SAML. Choose SAML as the client protocol, and that's all we need to create there. In the in the client settings on Keycloak, there's one thing we need to change, and that is to add to the valid redirect URIs setting a pattern or a complete URL, or one or more patterns or complete URLs that are valid redirect URIs back to our application, so that when Keycloak sees the initial redirect from the service provider to Keycloak, there'll be a redirect URI provided there. So this is just allowing Keycloak to sanity check that redirect and make sure that the application is asking to be transferred back somewhere reasonable. So what we need to do here is just add, that is not the one I need to add, F26 PyConAU.ipa.local SAML /*. Okay. And we can save that. Now, back in our application config, I'll just grab a snippet of SAML configuration. So the Apache module that knows how to talk SAML is called mod-auth-melon. And what we're doing here in this configuration is enabling SAML authentication at that subpath of our base URL for our app. So when we hit /SAML at our application, the mod-auth-melon machinery is going to kick in, and that's what's going to cause us to be redirected to Keycloak and then onwards to GitHub to log in. There's a bunch of files here that we don't yet have, and they need to be retrieved from Keycloak. They contain certificates and private keys for the client and the public key in terms of a certificate for Keycloak. For OpenID Connect, there needs to be a mutual trust relationship between the service provider and the identity provider, which, from the point of view of the application, is Keycloak. So, back in the Keycloak settings for this client, if we go to installation, we can grab some model of Melon files, a bunch of other formats as well if you want to use it with JBoss and Wildfly. It's going to give us a zip file to download. I'm going to, whoops, try that again. So I'll save that file. Sorry about this, my year of the Linux desktop and all that. Just bear with me a moment. So I just saved that in my home to, I will copy that across over to the web server, and then back in the web server, I'll just drop out of VI. There's another thing I meant to remove before the talk. Now I can unzip that file into this directory. And if we have a quick look in F26 SAML, F26 PyConAU SAML, sorry, we're going to see these files here, these configuration files that are referenced in the model of Melon configuration. In these files, there is just one thing we need to change, and that's in the service provider metadata.xml. This is not a SAML assertion, this is just a configuration file for model of Melon. You can see it contains a certificate for the service provider and some other metadata. The thing we need to change here is the assertion consumer service, which is the thing that runs when we redirect back to the service provider from the identity provider. And we need to instruct model of Melon where to actually mount this within the application, so to speak. So at what URL is this assertion consumer service going to be made available? And it will be f26 pyconau.ipa.local/saml/melon/post response. Okay. Now, let us restart Apache. And then over to our web application. Now, if we reload this, nothing's happened, but we haven't visited /SAML yet. If we do that, actually, before I do that, I will open up. Oh man, this is. Which one is the network things? Ah, there we go. Okay, good. We'll visit /SAML so we can actually see where the browser's going and what the responses are. Okay, cool. So just HTML things. Okay. So first of all, we saw we got a 303 redirect when we hit SAML. And we landed at, SAML details. So instead of a direct redirect to the IDP, it gives a direct redirect to another resource at the service provider that contains a form that automatically posts itself over to the IDP, SAML detail. Don't need to worry too much about that. The result is we landed at Keycloak, and Keycloak here, because of our earlier configuration, has given us the opportunity to log in at GitHub. I will click that. And now we've gone over to GitHub. If you'll recall, I already had a login session at GitHub, but it's asked me to authorize, do you want to allow the application we created, PyConAU fedauth, to access my account and to read my personal user data? We do. So I'll say authorize Fraser Tweedale. Oh, that wasn't supposed to happen. I wonder what I didn't configure right. Well, unexpected error when authenticating with identity provider. I wonder why that did happen. Just let me double check my config here, but we don't have long to spend doing that, so I'll just move on to the next scenario if I can't work this out in very short order. So GitHub, client ID, client secret. Have I pasted the wrong thing in there? I think I may have. Okay, let's try again. Okay, this time I'm already authorized. Oh, it doesn't work. Okay, never mind, we'll move on. Demo God's not smiling on me today. So, that is a broken version of this scenario. Okay, so the next scenario that we're going to look at, we're going to use Keycloak again, but this time we're going to connect the application to Keycloak using OpenID Connect. And we're going to have Keycloak authenticate to an LDAP server rather than to a social auth provider. So let's get into this configuration. And just as I had with the SAML, here's one I prepared earlier, which will be app.conf.oidc. The configuration is for the modauth OpenIDC Apache module. We need to give it provide a metadata URL. And rather than all of those files that we had to configure modauth melon with, in the case of OpenID Connect, there's less configuration overall. We point the OpenID Connect implementation at this URL, and I should point out that everything from here onwards is actually part of the standard, so it's sort of part of an identity provider, discovery and metadata publication part of the standard. So this is where it can learn what is the identity provider's public key, where do I go, which endpoint do I hit to retrieve user information, and so on. We actually haven't created the corp realm yet, but this will be the URL, and that will be the client name. We explicitly configure a redirect URI, just like with the SAML. We said, hey, we're going to mount all the SAML things at this endpoint. In the case of OpenID Connect, we say this here is the endpoint for our OpenID Connect redirect. The crypto passphrase is just for encrypting cookies and session data. Remote user claim tells modauth OpenIDC which claim in the identity assertion to use as the remote user environment variable in our application. And then finally, we turn all of this on at the path /OIDC. So before I restart Apache, we'll jump back into Keycloak. Create a new realm, which we'll call corp. We'll add an LDAP provider, which is under the user federation option on the left. I have a free IPA server set up on another host, another virtual machine running on this machine. IPA uses Red Hat Directory Server or 389DS, so most of this is correct. We just need to change NS unique ID attribute to IPA unique ID. Don't worry too much about those details. Connection URL will be LDAP S F250. users DN, yep, so that's the base DN for all the users. Bind DN, we'll use an unprivileged account. Okay, let's test the authentication. Mate, nothing's working, is it? Error when trying to connect to LDAP. How bothersome. Just let me kick DNS mask in the head. I think I might have a DNS issue on my VM host at the moment. That is truly exasperating. Well, I do sincerely apologise for the total failure of all of my demos. But the problem here is that Keycloak can't talk to the LDAP server. Not exactly sure why, but something has gone awry with the networking on my machine. In any case, let's just see how far we get, and then we'll quickly move on and wrap up the presentation and try and forget that this ever happened. Right, so to configure the OpenID Connect client, again, we'll go back to clients. In the corp realm, we'll create our F26 PyConAU. Yep, that's right, yep, because the F25/-0 is the LDAP server. Yeah. No prize for guessing which versions of Fedora these various hosts are running. So that'll be the client ID there. OpenID Connect is correct. We'll save that. Again, the only thing we need to adjust here is to tell Keycloak what the valid redirect URI or URIs are for our application. Which in this case will be the one we configured in the modauth OpenIDC configuration here, OIDC redirect URI. This one here, that's what we chuck in there, and then we can save it. Now I will restart Apache again to load the new configuration. Right, back to our app. This time we'll visit /OIDC, which will activate all of the modauth OpenID Connect machinery we've just configured. It will redirect to Keycloak. Keycloak, oh man, hang on a sec. Just let me do this. Oh, yeah, okay. That was using not TLS. I wonder if that was the problem. Anyway, no time to revisit that. So we see no social login in this realm, just the username and password. And I'll log in as Alice. And this is going to fail because for whatever reason, Keycloak couldn't talk to LDAP. But if that had succeeded, Keycloak would look up the user information from the LDAP directory, build an identity assertion, a JWT, because it's going to talk OpenID Connect, redirect back to the application, and then we'll land on the application and see a lovely list of the environment variables that modauth OpenID Connect has populated into the application's environment containing the various identity assertions. Okay. Yeah, LDAP groups, yeah, email address, and so on. Right. That's the one I want. Okay. So that's a lovely diagram of what didn't work. If you're using not Apache, NGINX has a paid and supported plugin for doing OpenID Connect. Oh, that jolly, there we go. By the NGINX, by the company that develops it. In terms of free software, there's a Lua plugin for NGINX. I don't use NGINX much, so I don't know about the details of how this works. But there's a Lua plugin for doing OpenID Connect. Ping identity are kind of big in this space, so I'm presuming it's quite, feature complete and works well. Please feel free to tell me otherwise if you've used it or tried to and found otherwise. So in the web frameworks for Django, for doing all the social auth things, use Python social auth. There's a bunch of different packages for doing OpenID Connect within your application itself, as opposed to the offload the work to web server modules approach, which is what I attempted to demonstrate earlier. And similarly for SAML, there's a package for that. If you do want to go the remote user approach, the main advantage of which being you can configure different applications using different languages in the same way. So if you're a very sort of multilingual organization with different services written in different languages, for consistency, you might take this approach. Otherwise, some people will recommend that it's preferable to push this logic down into the application rather than have the web server itself deal with it. So there are some docs for Django about how to deal with the remote user environment variable approach. And there's a resource here by one of my colleagues, that's the bottom link, going into more detail about this approach, and also looking at how you do it for Kerberos authentication, TLS authentication, looking up attributes from LDAP directly, and so on. For other Python frameworks, Python social auth supports all of the main Python frameworks. And there's a general SAML2 package with some good documentation about how to use it with different frameworks. And I couldn't find a similar resource for OpenID Connect, but if you want to use OpenID Connect in an application for a particular framework, just search for that exact combination, and chances are you will find some information that will help you do that. The general guidelines, if you're not using a Python framework and want to use the let the web browser do the authentication and just hand off environment variables to the application, basically you use middlewares to interpret the request environment, to build your user model, to establish the session, and so on. In those middlewares, you can map from the remote identity provider's role or group assertions into the groups or the roles that your application understands. You'll need to address the question of whether you need to persist the user model in your application, or whether it is sufficient to just have transient users. So you just have a user object that lives in the session, and once the user logs out, it just disappears and you haven't persisted anything. Most applications you will actually need to persist user data, but if you don't need to, then don't, because otherwise that's just extra data you have to store and maintain. And you may need to tweak the login view. Often the default login view in a particular framework will not observe the remote user environment variable and just proceed to redirecting to the landing page. If that's the case, you can build a new view, wrap up the logic, but perform that interrogation of the environment manually to see, hey, do we have a remote user already? And if so, don't show the form, just skip straight to the landing page via a redirect. So wrapping up, what do you need to use this approach securely? First and foremost, use TLS everywhere. If you don't, the protocols are not secure. You need to look at how secure are the libraries that you're using to implement these. As you saw earlier, there's a bunch of different libraries for different frameworks. Even for a single framework, for Django, there's probably 5 different OpenID Connect implementations. Whichever one you choose to use, take a good long hard look at it, see if it's secure, see if it has a large community, if they're responding to tickets, if it's being updated regularly. These are good indications that either it's going to be secure or that they're in a good position to respond to security issues if one is discovered. How secure are the protocols themselves? You'll see some links at the bottom in the footnotes. Those are links to academic papers describing formal analyses using model checking of the security of these protocols under particular assumptions, including OAuth 2, which is the foundation of OpenID Connect. That was done, I think, last year or late 2015, the OAuth 2 one. And they found some critical issues in the protocol that have now been fixed. For OpenID Connect, if you assume the security of OAuth 2, it is secure provided you follow the implementation guidelines outlined in that paper. If you are going to implement an OpenAuth 2 identity provider or a client, you must read that and make sure you follow those guidelines. There's also an analysis for SAML. SAML is secure under the assumptions outlined in the paper. Yeah, I have a final point here, preventing token or data interception at the user agent. In a lot of cases, the information you're going to get from the identity provider is going to contain rather benign information like what the username is and so on. Okay, it's not great if some malicious script running on a page gets a hold of that, but the damage might not be that big. But what if your identity provider is the government or the tax office and you are an accounting application? You might need to know the user's tax file number or information like that. In that case, you don't want those assertions traversing the user agent in a way where scripts on that page can read them and then exfiltrate them or use them maliciously. So how do we prevent this? That's what this step here is, the get user info step. After the service provider receives a token, the service provider can authenticate with the identity provider, present that token, and can retrieve that information directly from the identity provider so it doesn't have to traverse the user agent. So that's the approach taken in OpenID Connect. And so this is called an authorization code workflow. And you post to a token endpoint using the authorization code, and you get back your signed JWT from the identity provider containing the information that your service needs. In SAML, the way to do this securely is you actually get an encrypted SAML assertion. So you'll remember all of those configuration files containing, among other things, a certificate and a private key for the service provider. That allows the identity provider to encrypt the SAML payload, the SAML assertion payload, so that even though it traverses the user agent, anything running on that page can't actually decrypt that and inspect it. There are challenges around testing for when you want to go and deploy this, particularly in the social login case. A lot of the providers don't have test endpoints that you can actually verify all of your stuff works. You basically go live and, hopefully you have, if you're a large service, some way to, roll a feature out to only a small percentage of users or maybe just people who are employees of your company to allow you to verify that everything works. Email verification. If you get an assertion from an IDP about a user's email address, do you treat that as valid? Do you need to further verify that the user still controls that email address? The exact answers to these questions are things that you as writers of services need to decide is correct for your application, but you need to think about these things and think about the implications of doing it or of not doing it. If a user's, and the same applies not just for email address, but for any identity assertion. Do we just treat the username as valid? or not? Do we treat their roles as valid or not? Is this information potentially stale, or can we trust that it's fresh? Depending on the nature of your service and the identity provider you choose to use, you'll need to address these questions in a way that's relevant to that context. Account linking is kind of a hard problem if you're using multiple social identity providers. For example, if someone logs in using a social account that hasn't been used with your site before, but the email address asserted by that identity provider matches an existing account in your service. What is the correct behavior? Do you merge the accounts? Do you offer to merge them? If you merge them, do you need to do additional email verification? You need to think about the possible things that could happen and decide what is the correct behavior for your users. So should you use SAML or OpenID Connect? If it's a new thing and you're building it from the ground up, use OpenID Connect, provided your identity provider supports it. One important difference between OpenID Connect and SAML is that OpenID Connect supports workflows for non-web clients. So if you have mobile apps or desktop apps that need to authenticate to your service, where that authentication is actually performed by a third-party IDP, you want to use OpenID Connect. SAML just doesn't support it. If your service provider only speaks one protocol and the identity provider speaks the other, use a broker to translate between the two. If you're using multiple upstream identity providers, a broker makes that easy. Another important thing to note about brokers is that for those email verification questions, do I need to re-verify the email or not? Brokers like Keycloak give you ways to configure and automatically do that, so you can actually offload a lot of that work. What happens when a user signs out? Do we need to inform the identity provider? Or if they sign out at the identity provider, do we need to somehow find out and also sign them out of a service? So there's a single sign out sort of substandard defined for SAML, and there's one in draft for OpenID Connect. There are two main approaches. One is a back-channel approach, where when an identity provider, when a user logs out of an identity provider hits a service provider at a registered callback to inform it that the user session for a particular user is no longer valid. The front channel approach is that each service will load an iframe in the user agent. That iframe will poll the IDP to determine if the session is still valid, and when it isn't, it will then inform the service provider directly. So in that case, there's no direct communication between the IDP and the service provider to affect a single sign out. So, summing up, you should look at socializing or centralizing your authentication, particularly within an enterprise and organization where you know every user is going to have an account on your identity management system or in your LDAP server. For social login, there are integration opportunities and the opportunity to relieve your users of managing another identity and have them avoid an explicit login step that they would otherwise incur that stands between them and what they actually want to do at your service. Identity brokers can help and can do a lot of the heavy lifting, but you might not always want to use one. And you can use an approach where the web server does all of the work of these protocols and then just presents a consistent environment to applications, especially useful if you're running applications written in a lot of different languages. And that's the end of my talk. Are there any questions?
Hi there. You know, with the redirects that are being done to take you back to an HTML page, and with more websites doing a lot of asynchronous, you know, XML HTTP requests, it seems to be I've run into problems before where, you know, it's expecting a JSON response the cookie's expired, you suddenly need to re-authenticate. And it's not clear what the best way to do that is, because, you know, basically what we're doing at the moment is looking for an HTML response and then reloading the full page to kind of redirect to that HTML form. Just wondering if there's any plan to support like a JSON-based redirect, or whether that's even possible.
Well, I think that problem exists entirely apart from federated authentication and protocols like SAML and OpenID Connect. Even if you just have the service provider and the user agent, if you're using XML HTTP requests or WebSockets to talk to that server, your service provider, and the session expires, then that problem occurs anyway, and you need a way to deal with that in the application. It becomes only slightly more complex when you bring a single sign-on protocol into the mix, because you now have an additional party to deal with. But the problem doesn't occur because you've done it that way, because you're using an external IDP. And it doesn't go away if you don't do that. So how you address that in the application, I don't know, it's an application-specific problem. I think the idea of you know, a JSON response and some native browser support for refreshing a user session without having to reload the page is useful, because we've all experienced that situation that you've described, where you know, you're doing something on this site, you've possibly got a lot of you know, work executed on that page, for lack of a better term, and suddenly it all goes away because the page breaks because of the problem you've described, or it is handled but redirects you and you lose all your work. So it is a problem. I think a unified solution would be good, but the problem exists regardless of federated auth.
That's all the time we've got, and we've got afternoon tea now. Very, very brave doing that much configuration of software live, so thank you very much for your efforts, and please join me in thanking Fraser.